Welcome to part 6 of the Microsoft Access tutorial. We were talking in our last tutorial about different types of database relations, uh, particularly one-to-many, many-to-many, and one-to-one. We're going to recap a little on that. There are three principal types of relationship we want to pay attention to when we're constructing tables. They underlie the logic of queries and how information is hierarchically organized. A one-to-many relationship has one characteristic and several different examples matching it, such as a cat which has many different breeds. Assume in this instance, um, each one of these varieties of cat is a breed that doesn't overlap with another. That's just theoretical. Um, I suppose I could have made the cat, lion, house cat, and civet or something, to eliminate the contradiction. But assume these types of cats don't breed. Each one is a separate, distinct, exclusive example of what a cat is. And a one-to-many relationship has, of course, one characteristic on the left and many on the right. But the ones on the right all represent one type of cat, one type of animal. And in it where we were working in the tables in Access, we had employee name in the employees table and orders in the orders table. And of course, multiple orders can be matched to a single employee. So employees on the left is each employee is a unique instance because employees are listed only once in that table, but employees are repeated in the right table because each employee has made more than one order. If you look over to the right, you'll see exactly what I mean. Um, Tammy has one person, Tammy has four orders, one person, Jay, has one order, but one person, Jackie, has two orders. Um, as long as there's a potential for one person to have more than one order, it's a one-to-many relationship. To reiterate, a one-to-many relationship has a unique instance in each column of one table, unique instance in one row of each table, and repeated instances or potential repeated instances in the column in the other table. Um, in our particular employee table, we also have another potential one-to-many relationship, i.e. the order number. This isn't really, just for simplicity, I didn't include multiple items in any order. So a one-to-many relationship is not really discernible here, but it's a potential one-to-many relationship because you often have multiple items in an order. I just didn't have that in this instance. Um, in the real world, usually you'll have multiple items in one order, and so order number would be repeated a few times, but it would still be a one-to-many relationship because each item ordered would be different or potentially different. I'm making it a little complex. Just one-to-many, think of the diagram of cat to different types of cat. And then we have the one-to-one relationship. We did this before. Um, you can only have one instance on the right and one instance on the left. You have unique executive titles on the right and unique persons on the left. That way, a one-to-one relationship occasionally gives you an opportunity to split into two different tables. If a table with a lot of one-to-one relationships contains potentially information that could be more rationally organized in two tables, you can split the table along one of the one-to-one relationships. And then, of course, there's the many-to-many. Um, this is, of course, the thing uh, you want to turn a many-to-many relationship is chaotic, and the idea is to split up the information enough so that all your relations in a table are one-to-one or one-to-many. You do that by adding more columns, further dividing information by different types, or dividing it into tables. Many-to-many is a situation which can't really be managed in a prudent database. So let's rationalize. What I really wanted to do here was rationalize the one tables uh, that have many one-to-one relationships and split them up. So we had here the one-to-one relationship. Um, the executives are on the left and their titles are on the right. Now, imagine we have a table. It has a primary key to keep it organized. The executive title, each one of them is unique. Executive name, each one of them is unique because each position is occupied by a separate person. There are some companies where an executive will occupy more than one title, but we'll ignore those for here. Each executive has their own address, except two executives seem to be living together in the same building, perhaps. Um, then you have executive license plate. Two executives appear to share a car. And then you have an executive pay code. Different executives are paid out of different accounts. And then you have office number. You can see some executives share an office. Um, so what we want to do is we can divide the personal information off out into a separate table, uh, making two tables, one of which contains the business information and one of which contains the personal information. That way, um, when you update the information on the executive, um, you don't necessarily have to update the personal information. So let's look at rationalizing tables. What we have here is a large table. We want to divide it into smaller tables to make more sense of, to make updating more efficient. Of course, a one-to-one, when you find a one-to-one correspondence inside a table, this might be an opportunity for you to split a table off. Um, Here we have personal information on one column and business information on the other. Perhaps we want a table with just the personal information. That way, if we update the business information, we don't have to also update uh, that part of the table with the personal information, and vice versa. Um, the fewer the fewer columns you update, the less chance of data transcription error you're going to have. Of course, this is a very trivial example here, but when you're dealing with a table with millions of records, um, the savings can be substantial in terms of time and resources. Here, of course, you have a table with a bunch of information. Some of it is relating to personnel, and some of it is related to the titles that those personnel have. You might be able to divide this table into two, one with the personal information and one with the business information. So the first row, of course, is first column, of course, is primary key, which has no semantic information. But we have the first semantic title, first semantic column is business positions. Then we have names, home addresses, license plates. Imagine we have company cars, pay codes, and executive office number. So we have personal information, and perhaps we can split that off into a separate table. That way, if an executive is replaced, we change his name, but we don't have to change his office number, um, his pay code, and we'll just give him the car with the license plate already on it from the previous one. And we'll give him the same title. That allows us to efficiently update one record, one table instead of two. Um, and you can see in this instance, executive title and executive name in this column, in these two columns, all are non-repeating, one-to-one correspondence. In some companies, you may have a person occupying more than one position, but not here. Um, but you will see under home address, you have two executives living in the same house or at the same address, unless it's an apartment building. And you have two executives sharing the same car. It's a company car and same office. Um, and two executives have the same pay code. So those are not one-to-one correspondences, but the two principal columns, uh, name and title, are one-to-one correspondences. No repeating on either of them, no overlap. Opportunity to divide into two tables. Um, and here they are highlighted. Um, each title is distinct and each person is distinct. How do you split the table into two? Well, outlined in red are all information, is all information related to the business position. Outlined in green is the personal information. And outlined in blue is what would be the shared column, the join condition between the two. You could also have the name as a join condition, I guess. Either of the two columns that have a one-to-one correspondence could be the join position, join condition. In this case, I just chose the executive title. Makes it neater, um, makes it neater at least for the business information table. If you change the nature of the executive title, you're going to have to update two tables. That's just the nature of having a join condition. But otherwise, if you want to update one of these tables, either business or personal, you won't have to update the other, which is the convenient factor. And how do you do it? You just copy and paste the existing table and edit out, split, copy it, and duplicate it using the copy and paste process. And just delete unnecessary columns from each resulting table. So let's try that. Here's the executive personal. This is the table. And we're just going to close it. I'm going to copy it using the copy feature and paste it in the tables. Now, of course, it's going to have a slightly it's going to change type, the name's going to be different. It's going to be copy of executive personal. So you have executive personal, copy of executive personal. Let's change copy of executive personal to personal. Let's change executive personal to executive. Now, you can't do this after you've started building queries on top of a table. This has to be done early on in the database creation process, because any queries you've built on top of these tables are now not going to know where to look for their information. These are simple throwaway tables, it's not a big deal, but um, later on you would have to delete or reconfigure any queries that depend on these tables or any other tables that derive information from these tables. So we're going to go into executive, into datasheet view. We're in executive, so we're going to delete executive name. And you would get a warning if there were queries based on this that you wanted to delete. It would give you a warning before allowing you to delete. It might not even let you delete. Delete executive home address. Now all the information in the executive table is related exclusively to the business. And of course, the join condition with the other table is executive title. Let's go to personal. We're going to delete license plate and pay code and office number. You'll notice each of them also still has their own primary key. They happen to be identical. Let's see. Delete the field and all its indices. You can delete the indices here. I haven't made any indices. Access made one already. They make them they make them automatically sometimes. An index is an underlying method by which the database is kept intact. You can manipulate it if you wish, but it's a way that the computer keeps track of things. It's very useful, but we haven't gotten anywhere near indexes yet. So now we have two tables which are completely separate except for the join condition executive title. So now we could query these two to bring back the original table, or, but we can also keep them separate. Again, the virtue of this is you can change the office information without changing the personal, without having the risk of a rewrite error on the personal information, keystroke error, or a disk write error. Also, this is useful because it might keep the name of the personnel private. Personnel information needs to be more closely guarded today than it used to be. So you can have the generic information about the executive's position out in public without their home address, and with lower level employees without even their name, because you want to protect as much information as possible. So that is how you can use a one-to-one relationship. Again, a one-to-one relationship, in this instance, executive title and executive name, as a clue that you're able to divide a table into two for more efficient and safer operation. Now I want to look at calculated values. Calculated values, like you use in a spreadsheet, don't necessarily have the same significance in databases. There are some database gurus who say don't have calculated fields in a database. Save that for data reporting and spreadsheets. But the function exists, and it's useful enough. And we've already done one calculated value by just entering a little equation in the table, in the query field of the table. I'll show you that, and I'll show you a more robust way of entering calculated values. What is a calculated value? Again, calculated value is just adding two values up and putting them in another cell in the row. So add the value of one cell in a row to the value of another cell in a row and put it in a new third cell in a row, or divide one cell by another, or take one cell and multiply it by a scalar like number 4. Multiply every cell in this row by 4 and put it in the column in the next column. We've already done simple calculations. You may remember if we wanted to only return rows with a value 4 in a particular cell, we only wanted to return rows that where the value in a certain column matched 4, we would enter equal 4 in the criteria field. Greater than 4 if we wanted to return all the cells in the column that had value greater than 4. We had an OR where we could specify a range. What we also did was create a column which would add 2 cells in a row together into a third row, into a third column. So if we want a total, we add actual charge cell in actual charge column and shipping charge cell in shipping charge column for every row, and put it in a new column named total. And we specify this in the field section of the query builder. And we even specified the name of the column by adding the name of the column, which we made up in front with a little colon. This was just entering calculations directly into the query builder. There's also something called expression builder, which is a more deliberate and legitimate way of doing it. Expression builder allows you to insert a new column anywhere you want. Go into design view and you insert a new column using the insert rows key. You're inserting a new column, you're inserting a new row in the design view. And then you fire up the expression builder, which is in the, you select calculated as the data type when you're creating this new column. Name the column total, and then you select that it's going to be a calculated field, and the expression builder shows up in a nice little box, and you're going to type the calculation in the expression builder box. You can type much more advanced calculations using the expression builder box than you could type in the little space you have available in the query design. This is what it looks like. We'll be demoing this, so don't let this scare you. I want a new column, and it's going to contain the total of 2 other columns, actual charge and shipping charge, for each row. It's going to take actual charge in each row and the shipping charge in each row, and put it in a third column, a third cell, which matches the row, and all those totals sit in their own column. And so what we did here was name the 2 columns we want added up. Actual charge plus shipping charge. You'll see there's square brackets and a plus sign. That's the grammar you have to, the syntax you have to use. The system helps build it for you. And that's how you specify what the totals column will have. And then you hit OK, and you have a new column which totals up every row in a new cell in a new column. You can also open Expression Builder after you can edit the expression after you've created it and saved it by hitting the little ellipse in the query design view. So let's do it and show you what it looks like. Orders has actual charge and shipping charge. This is a table, of course, this isn't a query. We want a column which has the total. So go to design view. Of course, here are all the columns laid out here in each column name, one underneath the other in design view. And so we're going to insert a column, insert row. We are inserting a column. We call it total. And we're going to select calculated. And it automatically brings up the expression builder. And you can click on click on whatever items you want to sum. We want to sum shipping charge and, or no, not shipper. We want actual charge and shipping charge. And it brings up a little form that you change to correspond to what you want. We're going to put a little plus in there. Actual charge plus shipping charge. We could do actual charge multiplied by shipping charge if we wanted to. Actual charge plus shipping charge. Now, of course, these are two numerical fields. You get an error if you try and add two things which are not numerical fields. Okay. And now I'm going to close it to save it. And now let's look what it looks like now. There's now a totals field, which has been included now. So it's very simple to go into Expression Builder in design mode, and we could even highlight the total field, and we could go in and alter it if we wanted to. Shipping charge minus actual charge minus shipping charge if we wanted to. And that would change the value that shows up in the new column. So that's how to do it with a single table. Let's close it to save it. Now we can also do conditional expressions in a expression builder. Create a row which fires off information should, what we have here, for example, imagine shipping via UPS triggers some kind of violation. Imagine they don't have the proper customs documentation, say, or it's a violation of company policy because we don't want to pay for UPS. If someone enters UPS in the shipper field, this new column says violation. And if someone enters a different shipper in there that's not UPS, it will say no violation. A conditional expression is basically if one condition, this result, otherwise a different one other result. Conditional expressions can get very complicated. They can have several different conditions. In this instance, we only have two. And this is what it's going to look like. We'll build the expression, and you'll see exactly what I mean. If we're going to create a new column called ship warning, and if the shipper is UPS, you're going to get violation as the expression that shows up in the new column, and no violation if there's if you're using a different shipper. And in this expression window here, in this expression builder, you can see what it looks like. It's a little more complex. It uses conditional language, which looks more like symbolic language. You have the letters IIF, meaning if and only if. Uh, if and only if shipper equals UPS, then the column or the cell reads violation, otherwise it reads no violation. It does not look very pretty. Uh, the language is not intuitive, but it's easy once you get the hang of it. It's very efficient. Um, so let's do that now. The language is also reproduced up here in white. IIF, if and only if, shipper equals UPS, violation, otherwise no violation. The structuring of these parentheses and brackets, columns, commas, equals, and quote marks has to be very precise, but comes very quickly with practice. Basically, you have to make certain um, all the all the quotes and parentheses match each other. Um, you only need to, this is an example of a very simple conditional relationship just to show you what it looks like. So let's create this. Okay, orders. And we have all the different shippers. I've created ship warning already, so let's go into design view and see what it looks like. I'm going to delete it just so we can rebuild it. Okay, we're going to go into design view. Insert row. I'm going to call it shipping warning. It's going to be calculated. So it opens up expression builder. IIF. And it brings up a generic expression of the syntax so that it can kind of help you guide how to build it as you go along. If shipper equals UPS, comma, warning, or violation. Comma for the default in the if shipper does not equal UPS, no violation. And we close with a parenthesis to match up the syntax, and we hit OK. Hopefully I typed this in right. Save the table design. And there we have it. I'll go over this again. Shipping warning is a new column. Whenever you have UPS, it says violation. And it's a calculated field, even though you're not using numbers. It's evaluating a string. It's evaluating an expression. It's technically doing a calculation. It's doing a logical calculation. So again, here's the language. IIF, if and only if, parentheses, shipper equals UPS, violation, no violation, close parentheses. These get more and more complex over time. It's very important to get the syntax right, but as you can see, Syntax Builder helps you do this. And so what you can also do is, as I said before, you can go into a query and build an expression inside a query as well. Query design. and expression builder can be used. Um, expression builder can be used in a query as well. Go into design view. Go to the top here, highlight column you want to work in, and select build. You have to hit it just right. Build. That brings up expression builder, which you can use to define information in any query that has the relevant stuff. So we have total here already. Total is actual charge plus shipping charge. So let's just, we're going to build an expression. Total plus 5, which is, imagine just a $5 surcharge. Hit OK. Run the query. And total is added, total plus 5 in a new column. So thanks for watching. I know it's a little complex, but today we recap the different types of relationship. We noticed a one-to-one relationship which allowed us to split one table into two. And we used calculated fields to create simple arithmetical expressions doing operations on 2 cells in a row and putting them into a third cell in a row. We also did conditional expression, evaluate the contents of a table, evaluate the contents of a cell, and if it's one thing, put something else into a cell next to it. If it's something else, or if it's anything else, put something else in the cell next to it. We will be using these a lot going forward. I hope they weren't too confusing. Thank you very much, and I'll talk to you again soon.